Hello everybody, my name is Saurabh and in this video I want to demonstrate the batching feature of the ZK Smart Wallet. So in particular, I would be illustrating it via the test that we have written. And so for this test, we have five five ZK wallets. So each ZK Smart Wallet is tied uniquely to an email. So this email is giving us one unique wallet and likewise for the other four emails. What we do next is then we initialize each of these wallets corresponding to each of these emails, and we send some funds to the created smart wallet, and then we try to spend funds from the wallet. So that is what this function does. In particular, it takes the initial amount that we want to send to these ZK Smart Wallets. So here we are sending 100 ADA to each of these ZK Smart Wallet. And then this user is like a very rich user. So this is some third party which will be funding each of these ZK Smart Wallets. I mean, since this is a test, these smart wallets are not already funded. So we need some third entity to fund these smart wallets. So that is what this is doing. And after we have funded, then we try to spend some amount of ADA. And I mean, inside the code here, inside, this functions code, we are then spending some funds and like creating a few outputs uh, from this function. So maybe I can like very quickly show that. So yes, these are the two outputs we tried to create next. Okay, so this is then the final transaction that we have received, but this is like for a single user, right? And then we put this transaction in some type. So we have this type, you need not worry about this type, but we are putting this transaction in this type and also some other information that is needed. So this is like for single user, and we do the same thing for each of these five users. So in this loop, in this program loop, we execute this function for each of the users. Okay, so we collect the results inside this variable. Now once we have the result, so this is like having five entries for this type, each of the entries containing the build transaction, and these transactions are valid in their own respect. I mean, we could have submit this transaction, it will be completely fine, but we want to batch these transactions together. So we have this function called as batch transactions. So this is what that does the batching, the ultimate batching. So I'll give a brief description about this function, but moving on for now. So uh, this like does the batching, and then we have the final batched transaction body, and then we want to sign this transaction body. So since we have modified the transaction, I mean, when we do this batching, we modify the transaction. So what we do, maybe now is the good time to explain like what this batch transaction function actually do. So we have found the individual transactions, and this batch transactions at a very abstract level simply adds each of these transactions. So if this transaction is having 3 inputs and 4 outputs, and the other is having some, let's say, x inputs and y outputs, so it will add the inputs of both of these transactions, and also it will add the outputs of both of these two transactions. Okay, so this is simply joining the inputs and outputs and the other fields of the transaction. This is like simple in idea, but it is very complicated in implementation, because when we join the transactions, the old redeemers are no longer valid. I mean, in the Cardano, when we run the Plutus scripts, um, they take some computer resources. We call them as execution units. And the execution units for the individual transactions are not the same of as the execution units of the combined transaction, right? So, I mean, execution units is like the cost that the Plutus smart contract takes, and the Plutus smart contract as its inputs take the basically the entire transaction. And since we have changed the entire transaction because now the transaction is bigger, that means the Plutus script is now running under a different context, and therefore the execution units change. So we need to like recompute the redeemers, and there are other things as well. So we have provided this function to save time. I won't go over its implementation because it's like really low level and complicated, so it's very intricate and it will take a lot of time to explain, but the code is there. um, it's quite readable, so you can have a look of like what we are doing here. We are using Atlas under the hood, so a lot of the functionality is also abstracted away from Atlas. I mean, by Atlas. So the code here is like, uh, I mean, it is already quite elaborate, but there is also some elaboration coming from Atlas because we are using it under the hood, and it is providing some really good features that help uh, for our purpose related to batching. But that is the high level idea that I gave. And so when we batch, each of the individual transaction are having some fees, right? So in the transaction that we submit to the ledger, this transaction is having multiple fields. It has inputs and outputs, and across those fields there is an entry for fee. So the transaction has an entry saying that this is the fee amount for me. So for the batch transaction, we basically sum the fees, and that is like I mean, we sum the fees for each of the individual transactions, and then in the final batched transaction that we have, we might actually require less fees than the sum of the fees of the individual transactions. So just to like recap, individual transactions is having some fees. We sum up the fees of the individual transactions to like to have the ADA that we can use for the fee of the final transaction, I mean the batched transaction. But the batched transaction might require less fee than the sum of these individual fees. So what we do in that case, the leftover we split equally to the different batched to the different individual components of this batch. So each of this is like one component, this individual transaction originally. So we split the additional leftover fee equally to these to all the components. So I mean this this logic is here. So we do this equipartition of the like saved fees, right? So then since the transaction is different than what we initially had, I mean now we have a bigger batch transaction, the old key witnesses are no longer valid. So these users need to like sign again the transaction. So they do this signing here, and then we submit it. So I have like already executed this test, so we can take a look. So I mean, this is a test suite which has multiple tests in it, but we are interested in the test related to the batching. So let me find the batched transaction test. I mean, it's the number of logs is like quite huge because we were having 5 users, so there is like log for each of those 5 users. But okay, we are here in the smart wallet batch test. So like most of the test logs here are like for this function that we had, where we are building the transactions individually. So I'll try to skip over them since they are not relevant, and move to the batching part. So I mean, you can see these are all the individual transactions. So let me find batching somewhere. There should be batching at the very last. Okay, so this is the batched one. Okay, so here we log the batched transaction body, and you can see it's like really huge compared to the individual ones. So this is like the individual transaction, and this is like the combined one. And you can see that for instance, for this individual transaction, if there is some input like this one, F99B, this input will also be present inside this batched transaction. So let me see if I can quickly find it. Okay, this one. So F99B. So this is the batching one, and we can see that there is some fee that is saved. So in this case, it's like 0.17 ADA that is saved, and then we submit this batch transaction. So this completes the batching functionality that I wanted to demonstrate. Thank you.